In this video, we'll be looking at inscribed angles. If you find this video helpful, share, like, and subscribe. Inscribed angles. So let's look at some terminologies and labeling in here. So inscribed angle, this is one of the best topic that we can study in this lesson. The definition of an inscribed angle in here is simply saying that it is an angle made by two chords with a vertex on. The keyword is on a circle. Okay. Okay, so let's look at some example of an inscribed angle in here. So here, let's name this circle A. Okay, I'm going to call this A. And what I do is, let's say from this point, I'm going to create one chord in there, and then this is going to be another one, and I'm going to put them together at one point. Now I'm going to label this as, let's say, E, F, and G. Now, what you're going to be looking at in here, if you're going to be looking at this part, this is actually an angle made by two chords, and this is what you call your inscribed angle. Okay, so let's name our inscribed angle here. So here, this is actually your inscribed angle. Okay, if you're going to be looking at its characteristic, the vertex is actually on the circle. Okay, so that's called an inscribed angle. So what is the name of this angle? Okay, it's actually named EFG. Okay, EFG. Okay, another thing that I would like you to look at here is the keyword intercepted arc. Okay, so if you're going to be looking at this arc, these are actually the arcs that is being intercepted by line segment EF and GF. Okay, let me write that keyword for you. It's called intercepted arc. Okay, intercepted arc. Okay, the name of this arc is called arc EG. Okay, is equal to arc EG. That is your intercepted arc. So by definition, if you're going to be looking at the definition of an intercepted arc, it simply says that an intercepted arc is actually created by angle having the same endpoints. Okay, so let's look at our example in here. So, okay, angles having the same endpoint. So we're going to look at again our angle in here, our inscribed angle in here. There you go. The endpoint in this here. This is your intercepted arc. Okay, so what did it say? Arc created by an angle having the same endpoints. Okay, I think that's gonna be very clear on you. Okay, so let's look at some inscribed angle theorem in here. The very first one that I would like you to memorize is this one. The measurement or the measure of an inscribed angle is actually one half of its intercepted arc. Okay, keyword, one half of its intercepted arc. So let's look at this example in here. So let's say the measurement of angle ABC in here, okay, the measurement of angle ABC is equal to one half of the intercepted arc AC. Okay, or we can also look at the other part of that. The counterpart is the measure of an intercepted arc is double of its inscribed angle. Okay, this is the opposite of this one. It means to say that from the inscribed angle, you are going to find the intercepted arc. What's going to be the size of this intercepted arc once you are given the size of the inscribed angle? So this is very easy because you're going from front, I call this front, going to the back. You're going to divide it by 2. Now, if you're going to be coming from the back, which is the inscribed angle, going to the arc, then you're going to multiply that by 2. Okay. Now, the next corollary to this theorem is very simple. I would like you to really, really understand this very well. Inscribed angles with the same arc have the same angle measure. Okay, so let's look at this one. What are the inscribed angles that we can see in here? So in this case, we can actually see the inscribed angle here. Angle A and angle B are actually inscribed angles, and it says here that they have the same measurement because they are actually lying on the same intercepted arc. Okay, so let's give you an example. So let's say that this is going to be, let's say 60, okay, 60 degrees. The arc is 60 degrees. It means to say that the measurement of angle A, which is an intercepted arc, will be equal to the measurement of angle B, which is going to be one half of this arc. Okay, let's label this one. Let's say C and D. Okay, of arc CD. Now let's look at this one. One half of 60 is going to give you 30 degrees. Therefore, this is going to give you 30 degrees and the other is also 30 degrees. Okay, so let's go for the next corollary. Okay, here this is a special case. The reason why it's a special case because it's actually going to create a semicircle. Okay, so here inscribed angle in a semicircle is a right angle. Okay, here, if you're going to look at this one, this is actually a semicircle, okay, with the diameter in there. So it says that any inscribed angle in a semicircle will create a 90 degree. Okay, so let me just stretch this a little bit more. So if, let's say, I'm going to create one more, let's say from here, and then I'm going to put it in there. If you're going to notice this one, this is not perfectly drawn. So it's going to create a 90-degree angle in there. So remember, this is special case. If you meet these examples in our practices and even in your quiz, always remember that this is a special case. Okay, let's continue with the next corollary in here. So the third corollary, which is also a special case, is talking about quadrilaterals, okay? Opposite angles of a quadrilateral inscribed in a circle are supplementary. It means that they add up to 180. So let's give you an example for you to understand it very clearly. So if you're going to say the keyword in here is actually called opposite angles, okay? So angle A, the opposite angle of it is angle C, okay? And this is going to be angle B, and the opposite of it is going to be angle D. Now remember that the corollary simply says that it's going to add up to 180 degrees. Okay, it means to say that the size of this angle opposite to each other is going to give you 180 degrees. That's why it's called supplementary angles. Okay, also with this one, this is going to give you 180 degrees. Now, always remember that in a polygon, all the sum total of the angles of a polygon, or a quadrilateral, sorry, is going to be a total of 360 degrees. Okay, next to this is going to be a tangent chord theorem. So I would like you to look at this one. This is a special case, but it's actually a very common sight when you're going to be looking at uh, this lesson on tangent and chord. So it says here that the measure of an angle formed by a tangent and a chord is one half of the intercepted arc. Okay, keyword intercepted arc. Okay, so let's look at this part. So if you're going to be looking at this part, we can actually see that the red part is what you call the intercepted arc by a chord BC in here, and there is a tangent line, that tangent ray I mean, that's going to be creating an angle in here. So if we're going to find the measurement of this angle in here, this one, okay, so the measurement of angle BCD in here, in this case, according to the theorem, it's going to be one half of the intercepted arc, and the intercepted arc in here is going to be the arc here, this one, B and C. Okay. Okay, so let's give you an example. So say for example, the size of the intercepted arc is, let's say, 80 degrees, just for example. So if we would like to find the measurement of angle BCD in here, so it's going to give you a total of 1/2 of 80, which is going to give you 40 degrees. Okay. Okay, so let's go to the last theorem that we're going to be looking at in here today. Okay, the tangent chord theorem. So first, let's recognize what are the tangent. So I can see a tangent line in here. At this line is going to be the tangent line. Okay, here is my tangent line, and the point of tangency is at point C. Now it says that in tangent chord theorem, the measure of an intercepted arc is twice or double the measurement of the angle formed by the tangent and the chord. So the tangent and the chord, it has created an angle, and they are telling us that as a result of that angle, the size of the intercepted arc is going to be 2 times of the size of this angle. Okay, so let's give you an example. Let's give you, okay, let's say this is going to give you, let's say 95. Okay, I know it's a little bit big, but let's say 95. So if we're going to find the measurement of arc BDC here, it says that it's going to be twice. So it means to say that we're going to find that one, the measurement of arc BD and then C is going to be 2 times the measurement of 95 degrees. Okay, so 95 times 2 is going to give you a total of 190 degrees. It means to say that this is going to be 190 degrees. I believe that the converse is also the same. It means to say that because if you're going to be looking at the angle in here, BC, okay, this angle, okay, let's say, let's add another one letter in here. BC, let's say A. Here, this is the A, okay? Although it's array. It's going to be, the measurement of this is going to be 1/2 of the intercepted arc. So if you're going to be looking at from here, from 90, and you're going to go and look at the size of this angle, that's going to be 1/2 of the intercepted arc. So 190 divided by 2 is actually going to give you 95, which is actually just like this inscribed theorem angle. Okay, remember this one, that if you're coming from the arc going to the inscribed angle, that's going to be divided by 2. But if you're going to be coming from the inscribed angle going to the arc, it's going to be multiplied by 2. So they are actually very related to each other. Okay, so this is all the things that you have to remember about the theorems on inscribed angle. Okay, how to find the inscribed angle or intercepted arc. Example number 1, let's look at this one. They're asking us for the value of A. So we said earlier, according to the first theorem, that the measurement of an inscribed angle is 1/2 of the intercepted arc. So let's write that one. So here we can say that the measurement of uh, angle A, let's say angle A is equal to 1/2 of the intercepted arc, which is 116. Okay, so 116 divided by 2 is going to give you 58 degrees. Okay, that's it. Okay, on your own, try this one. What do you think is the measurement of arc A in here in degrees, given that the inscribed angle is 90 degrees? Okay, so let's go back to that. Now, let me just show you something in here. So I would like you to look at the inscribed angle theorem again in here. So I said earlier that if you're coming from the arc going to the inscribed angle, that's going to be divided by 2. But if you're coming from the inscribed angle going to the arc, it's going to be multiplied by 2. So in this case, we're going to do or apply that concept. So I'm coming from the inscribe angle going to the arc, then I'm going to multiply it by 2. Therefore, the measurement of A in degrees is going to be 90 multiplied by 2, and it is going to give you 180 degrees. Okay, let's go to the next. Here they are asking us for the value of A and B. Okay, what are the information that we can see? Here we have the inscribed angle, and if I'm going to look at it clearly, the intercepted arc of this angle PQT is actually this arc PT. Okay, so what did we say about this theorem? So if coming from this inscribed angle going out to the arc, that's going to be multiplied by 2. Therefore, a degree here is going to give you 60 multiplied by 2. So the measurement of your arc of A in here is going to be 120 degrees. Okay. Now what about the B? Now look at the B in here. So if you're going to be looking at B in here, so remember this is going to be 120 already. Okay, and this is going to be 30. That's a total of, the intercepted arc for B is from P to here. Okay, so 120 plus 30, that's going to give you 150. So the B is going to be 1/2. Okay, so let's look at the total arc in here. What's the total arc in here? That's going to give you 120 plus 30 divided by 2. Okay, so 150, that's going to give you 150 divided by 2. So the size of this arc is going to be 120, this one, plus this one, 30 degrees. So that's going to give you 150 divided by 2. And the measurement of that angle is actually 75 degrees. Okay, let's go to the next one on your own. Okay, what is the value of A and B? Okay, the information given here are the sizes of my arc. Okay, I can see the size of my arc in here. This arc is 82 and that's 60. So that's going to be an easy fix because I will just subtract these two numbers from 360 to get A in here. So let's get into that. A degrees equal to 360 minus 82 plus 60 is going to give you 142. And if we're going to subtract 142 from 360, okay, from 360, this is going to give us 218. Okay, that's the answer to that. It means to say that A is 218 degrees. Now, if we're going to find B, that's going to be 1/2 of 218 because B is an inscribed angle. So 218 divided by 2 is just going to give you 109 degrees. Okay, that's as easy as that. Okay, let's go for example 3. What is the measurement of angle A? Okay, so in this case, let's say angle A. Okay, if you're going to look at the figure, it's actually a special case. Okay, the special case that an angle or an inscribed angle in a semicircle is always 90 degrees. So with this said, we can simply conclude that the measurement of angle A is equal to 90 degrees because of the special case corollary that we have done. Okay, this is a special case. Okay. Okay, let's look at this one on your own. What do you think is the measurement of angle 1 in here? Okay, this is angle 1 here. Okay, there's this, since this is a special case on semicircle, angles on a semicircle, we can simply conclude that the measurement of angle 1 here is equal to 90 degrees. Okay, regardless of these arc sizes that has been given. These are just information that they gave you about the circle, but they are actually asking you for the measurement of this angle 1. Okay, let's go to the next one. Here, what is the measurement of angle 2? Okay, So here the measurement of angle 2 is what? So let's look at this one. We can see that this is actually the intercepted arc for this angle, which is 38 degrees, and angle 2 is also lying on the same intercepted arc like that of 38 degrees, this angle. It means to say, and we can therefore conclude that the measurement of angle 2 is the same with this 38 degrees. This is also a special case, okay? So if you're going to be looking at these two angles, they are actually lying on the same arc, okay? They are lying on the same arc. Okay, therefore, they have the same angle measures. Okay, on your own this time, what do you think is the value of x degree and y degree in here? Okay, let's look at it. So, first, we can see a common arc in here, which is 72, right? That's the size of the arc of this. And if you're going to be looking at it, x and y are lying on the same arc. Therefore, the measurement of angle y, okay, angle x will be congruent with the measurement of angle y, which is one half of the intercepted arc, which is 72. Okay, 72. Now, one half of 72 is going to give you 36 degrees. Okay, so this is both of this is going to be 36 degrees, and this is also 36 degrees. Okay, let's go for number 5. So this is a theorem on quadrilaterals. Okay, well, let's see. What are the things that's given in here? Here I can see the red dotted line is actually a diameter. And this is going to create two semicircle. Okay, the first semicircle is on this side. Okay, remember this is your diameter. And the other semicircle is on this side. Okay, therefore, since this is also a special case, okay, that diameter is actually creating 180 degrees. And what did we say about an angle on a semicircle? It's going to form a 90 degree. So having said that, it means to say that this angle 3 and angle 1 are 90 degrees in nature because of the diameter. So here we can say that the measurement of angle 1 is equal to the measurement of angle 3 equals to 90 degrees. Special case, okay, this is angle. These are actually angles in a semicircle. Now, in the case of angle 4, here, angle 4 is the measurement of angle 4 is going to be one half of its intercepted arc. Now, if we're going to be looking at this angle 4, the intercepted arc is these two numbers, 60 plus 80. So that's going to be 60 plus 80. That's going to give you one half of 140. Therefore, the one half of 140 is going to give you 70 degrees. Okay, so if this is 70 degrees, yeah, 70 degrees, what do you think is the measurement of angle 2? Now remember that they are supplementary. So we're going to just subtract that from 180. We subtract 70 from 180. 180 minus 70, this is going to give you 110 degrees. Okay? Okay, try this on your own. Okay, what do you think are the values for each angle A, B, C, D? Okay, so first let's start with A. The measurement of angle A here is going to be one half of the intercepted arc. Okay, here of the intercepted arc BC plus arc CD. Okay, so one half, what's the size of our arc BC? It's going to be 100 plus your 90. So that's going to give you one half of 190 is going to actually give you 95 degrees. Okay, so that's going to be 90. So we're going to get its opposite, which is the angle C. Therefore, the measurement of angle C here is going to be 180. Subtract the measurement of angle A. So in this case, this is going to be 180 minus 95. Therefore, it's going to give you 85 degrees only. Okay, let's start with angle B. The measurement of angle B is equal to 1/2 of arc AD. Arc AD plus your arc CD. Okay, arc CD. So what's the size of our arc AD? That's going to be 1/2 of 64 plus 90. Okay, 64 plus 90 is going to give you 154. So that's going to give you 154 divided by 2. So if you're going to divide that by 2, that's going to give you 77 degrees. Now, so we're going to get its opposite, which is angle D. So the measurement now of angle D, the measurement of angle D is going to be 180 minus the measurement of angle B, which is its opposite. Okay, so that's going to be 180. Our measurement for angle B here is 77. Therefore, this is going to give you 180 minus 77 is going to give you 103 degrees. That's it. Okay, practices on scribe angles of a circle. State if each angle is inscribed angle. If it is, name the angle and the intercepted arc. Okay, here it is not an inscribed angle. This is a central angle. So in number 1, there is no inscribed angle. Instead, we have an central angle. So it's not. Number 2, yes, it is an inscribed angle. It's on the circle. And the name of the angle is angle, I'll start from here, LMK. Okay, here next, number 3. So is this an inscribed angle? Yes, it's on the circle. And the name of the angle is angle QPR. Number 4. Is this an inscribed angle? No. It's very obvious. It didn't even reach the other part of, it's not on the circle. That's what I meant. Okay, so let's see. Find the measure of the arc or the angle indicated. So here in number 5, this is very easy. The measurement here of angle RSQ is going to be 1/2 of 92. Okay, 92 divided by 2 is going to give you 46 degrees. Okay, so this is 46 degrees. Next, in number 6, this is a semicircle. Okay, special case. Therefore, the measurement here of angle ABC is equal to 90 degrees. Okay, this is a special case. What special case? That is actually an angle in a semicircle. Okay. Okay, next, number 7. So we are asked to find the measurement of this arc. Okay, so what did I say? There's the inscribed angle is given. So we're going forward, going towards the arc. So we're going to multiply this by 2. So the measurement here, the measurement of arc SR is equal to the measurement 2 times the measurement of angle STR. STR. It's going to be 2 times 37. Okay, 37 times 2 is going to give you 74 degrees. Yeah. Okay, this is 74 degrees. This one. Okay, let's go for number 8. They are actually asking us for this arc, question mark. Okay, so There is a special case in here. This is a diameter, and that's going to make a semicircle. And we say in our special case that an angle in a semicircle is always 90 degrees. So this is an inscribed angle, okay? So let's name this one. Okay, let's say JKL, this is M. Let's call it as M, okay? So let's see the measurement here, the measurement of arc here, J, M, and then L. Yeah, J, M, L is going to be 2 times the measurement of the measurement of angle here, this angle JKL, JKL, which is 2 times 90 degrees. It's going to give you 180 degrees. Now, it's going to confirm it. It's 180 because this is actually a semicircle. Okay, let's go to the number 9. Number 9, we are actually seeing an inscribed quadrilateral in a circle. Okay, so there's a question mark in here, but let me rename this one. I don't want X only. But let's say we're going to rename this question mark A, this angle. Okay, so what can we see in here? We can actually see that angle is created by this arc. I mean, this is the intercepted arc, and these are actually the chord that has created this angle. So this is going to be an inscribed angle. It means to say that it's going to be half of the total intercepted arc. So here the measurement of angle A is going to be 1/2 of arc EF, yeah, EF, plus the arc FG. Okay, this is going to be 1/2 of what's REF? Once that's going to be 120 plus 96. That's going to give you 216. Half of 216 is 108 degrees. So this is 108 degrees. So if we go further, if you like, the opposite of that is going to be, we're going to subtract 108 from 180. Minus 108, it's going to give you actually 72. So this is just a little bit of uh, doing it a little bit further, okay? So this is going to give you 72. Okay, and if that's 72 and this is 108, then it's going to give you a total of 180. So they are all supplementary angles totals 180 degrees. Okay, number 10 here, another inscribed quadrilateral in a circle. So here in number 10 says find the measurement of VWX. V, W, and X. So it's going to be the arc, this arc. Okay, so that's going to be, there we can see an inscribed angle in here, and it's 91 going from the inscribed angle going to the arc. We're going to multiply it by 2. Okay, that's gonna be easy. We multiply it by 2, so times 2. Therefore, we can now answer the question in here. The measurement of arc VWX is going to be 2 times the measurement of angle VFX here. Okay, this angle. The measurement of angle VFX, and that's going to be 2 times 91. Okay, 91 times 2 is going to give you 182 degrees. Okay. Find the measure of the arc or angle indicated. Number 11. So in here we are asked to find the measurement of arc PQ. Okay, here. So we have a triangle. The total angles will be equal to 180. Okay, 180. Having said that, so I'm going to say that the measurement, therefore, I would like to find the measurement of angle PRQ first. So the measurement of angle PRQ, sorry, PRQ is equal to 180 minus 98 minus 38. Okay, so that's going to give me 44 degrees. Okay, so this is 44. Now that I know that one, it means to say that I can just easily find the measurement of my arc. So the measurement here now of my arc PQ, arc PQ is going to be twice the measurement of my inscribed angle. Okay, the measurement of angle PRQ. So here it's going to be 2 times 44, and it's going to give you 88 degrees. Let's go for number 12. Okay, they are asking us for the arc again. Arc XW. This is also a special case because WY is a diameter. So it means to say that in our special case, it states that angles in a semicircle forms 90 degrees. It means to say that this is 90 degrees, and if a triangle is only 180, then this is going to be 30 degrees. That's going to be 369 triangle. Therefore, if we're going to answer this one, the measurement of arc XW is going to be twice the measurement of angle Y. Okay, twice the measurement of angle Y. And that's going to give you 2 times 30. 2 times 30 is going to give you 60 degrees. Okay, let's go for number 13. We're going to solve for X. Okay, so let's remember something in here. So whenever we solve for the inscribed angle, let's say the inscribed angle is going to be, let's say, X. In inscribed angle, the measurement of angle X as an inscribed angle is equal to 1/2 of your intercepted arc AB. Now, we're going to be doing the same thing. This measurement of angle X squared is going to be representing 74. That's going to be 74. We have 1/2, and this arc AB represents this one. Okay, so that's going to give you 28 plus 8. We cross multiply, so that's going to give you 74 times 2 is equal to 28x plus 8. Now, 74 times 2 is going to give you 148 is equal to 28x plus 8. Minus 8, minus 8. This is going to give you 28x is equal to 140 divided by 28 again. Therefore, our x is equal to, let's say, 140 divided by 28. This is going to give us 5. So they are just asking us for solving x. Therefore, we solved it already. So the value of x here is 5. Now, let's recheck. Now, 28 times 5 is going to give you 140 plus 8. Okay, that's going to be 148. Okay, so if we're going to do it, let's divide it by 2, which is going to give us 74 as our inscribed angle. So our answer here is correct. Okay, number 14. Here we have seen again another inscribed quadrilateral, but are just asking here. The good thing in here is we are just asked for the value of x on this opposite angle, which is a total of 180. So let's just equate that. So we can say this one 76 plus 21x minus 1 is equal to 180. Remember 180 because opposite angles are called supplementary angles totaling 180 degrees only. 76 minus 1 is going to give you 75 plus 21x is equal to 180 minus 75 minus 75, and we know that 180 minus 75 is going to give you 105. Okay, 21x is equal to 105, and we divide both by 21. Therefore, the value of x here is going to give us 5 also. Okay, so let's check. 21 times 5 is going to give you 105, minus 1 is going to give you 104. So this is 104. Now, if we're going to subtract 104 from 180, that's going to give us 76, which is correct. So our answer here is correct. Okay, let's look at this one. Find the measure of the arc or angle indicated. Number 15, find the measurement of angle X, Y, W. Okay, X, Y, W. Okay, so earlier I showed you that if you're going to be finding the inscribed angle, we have this formula, the measurement of, let's say, x degree is equal to 1/2 of the intercepted arc AB. Yeah, so we're going to make use of this one, 4x plus 17 as our inscribed angle in here. So that's going to give you 4x plus 17 is equal to 1 over 2 times this one. This is going to be like your intercepted arc. This is going to be 10x plus 10. Okay, let's cross multiply it. Or what you can do is actually you can multiply both sides by 2 here. Okay, so this will be cancelled out. Here we're going to multiply this one. So 2 times 4x is going to give you 8x. Okay, 17 times 2 is going to give you 34. Now, what is left in here is just 10x plus 10. Okay, it's easier for me to say minus 8x here, minus 8x. Okay, so what is left here is going to be 34 is equal to 2x plus 10. And then minus 10, minus 10, I'm left with 34 minus 10 is going to give you 24 divided by 2 divided by 2. And we know that 24 divided by 2 is simply 12. Okay, so that's the value of our x in here. So let's recheck. Let's recheck. So let's see, 4x, so let's say 4 times 12 is going to give you 48 plus 17. That's going to give you 65. So this angle is actually a total of 65 degrees. If that is so, that's going to be multiplying by 2. So we are going to be looking at this arc should be around 130 degrees. Now let's substitute the value of 12 to this. 10 times here, 10 times 12 plus 10. 10 times 12 is 120 plus 10 is going to give you 130, which confirms to our computation. Therefore, our answer as x equal to 12 is correct. Okay, so here's the last one. Find the measurement of angle LAN. Where is that? LAN. Here. Okay, angle LAN has the opposite angle of LMN. So they are opposite again, just like the one we did earlier. We're just going to equate it, and that's going to be a total of 180. So let's start with uh, LAN. That's going to give you 4x plus 21, okay, plus 6x plus 19 is equal to 180. I have 4x here, so they're going to be 10x. 21 plus 19 is going to give you 40 is equal to 180. Minus 40, minus 40, cancel that out. What is left is just 10x is equal to 140 divided by 10. divided by 10. My x here is just going to be 14. Now let's recheck. Okay, they are asking us only to find the measurement of this angle LAN. So in that case, the measurement now of angle LAN is equal to 4x plus 21. The value of our x is 14. 4 times 14 plus 21. Okay, let me continue here. Okay, 4 times 14 is going to give you 56 plus 21 is going to give you 77. So this is the measurement of your angle LAN. This is all for the lesson about inscribed angles. If you find this video helpful, share, like, and subscribe. Thank you very much.